Voyager 1 is the spacecraft that has ventured farther from Earth than any other human-made object, carrying with it a message meant to last for billions of years. Although it has spent over 45 years traversing the cosmos, it's still uncovering new mysteries each day. In a recent development that even renowned astrophysicist Neil deGrasse Tyson couldn't ignore, Voyager 1 picked up signals indicating the presence of 775 previously unknown celestial objects while exploring interstellar space. This discovery has sparked a flurry of questions. Are these 775 objects genuine features of our universe, the result of glitches or corrupted data during transmission back to NASA, or could they perhaps even be evidence of extraterrestrial activity? In this video, we'll take a deep dive into Voyager 1's latest findings and explore the possibilities behind these mysterious bodies drifting silently in space. Neil deGrasse Tyson, a well-known figure in the scientific community, an astrophysicist, author, and advocate for expanding NASA's operations, has long argued that our space agency is underfunded for the monumental tasks it faces. A Harvard-trained physicist with a deep passion for unearthing the universe's secrets, Tyson believes there is still so much we don't know about the cosmos. It's this perspective that makes the recent detection by Voyager 1 all the more fascinating, as it promises to open up new avenues of exploration into what lies beyond our solar neighborhood. Our home, Earth, is a remarkable planet filled with incredible features, but compared to the vast expanse of the universe, it is merely a tiny speck, a notion that has been contemplated by philosophers for centuries. It wasn't until the technological breakthroughs of the 1970s that humanity could begin to truly understand this cosmic perspective. That breakthrough came partly due to a rare planetary alignment. The four largest planets of our solar system, Jupiter, Saturn, Uranus, and Neptune, lined up in such a way that they resembled a string of pearls on a celestial necklace with Earth. This once-in-176-years event was uncovered by Gary Flandreau, a PhD student at the California Institute of Technology who was working part-time at NASA's Jet Propulsion Laboratory. While charting the orbits of these giant planets, Flandreau realized that during the late 1970s and early 1980s, the gravitational forces of these planets could be harnessed in a clever way. A spacecraft could use a series of gravity assists, each giant planet giving it a significant boost, almost as if tugging it along with an invisible cord, to dramatically cut down the travel time between Earth and the outer planets. In fact, calculations suggested that what would normally be a 30-year journey could be reduced to a mere 12 years. Seizing this rare opportunity, NASA set out to design two nearly identical spacecraft, Voyager 1 and Voyager 2. Although they share the same technical specifications, the twin probes were launched only 15 days apart during the summer of 1977. Voyager 1 itself lifted off on September 15, 1977, embarking on a mission to study the outer planets, the boundaries of the heliosphere, and eventually, interstellar space. Since its launch, Voyager 1 has served as a rolling observatory, sending back invaluable data through NASA's Deep Space Network. Thanks to this communication network, we can monitor its distance and speed in real time. As of August 2023, Voyager 1 was approximately 24 billion kilometers from Earth, making it the farthest human-made object from our home planet. The spacecraft, built by the Jet Propulsion Laboratory, left Earth aboard a Titan IIIe rocket from Launch Complex 41 at Cape Canaveral, following a carefully planned trajectory that allowed it to make pivotal flybys of Jupiter and Saturn. Although it launched after Voyager 2, Voyager 1 reached Jupiter first, capturing detailed images of the gas giants and their moons, and offering unprecedented insights into their magnetic fields, atmospheres, and ring systems. The mission didn't stop there. After its impressive planetary flybys, Voyager 1 continued on a path that took it to the outer edges of the heliosphere, the bubble-like region of space dominated by the solar wind, and ultimately into interstellar space. On August 25, 2012, it became the first spacecraft to cross the heliopause, marking its entry into the realm between the stars. 2 years later, in 2014, Voyager 1 provided us with a family portrait of the solar system, a famous image that includes the iconic pale blue dot view of Earth from afar. Even though the mission was originally expected to end many years ago, the ingenuity of NASA's engineers has kept Voyager 1 operational until at least 2025. In late 2017, for example, engineers reactivated its trajectory correction maneuver thrusters, the first time since 1980, to extend its mission life by another 2 to 3 years. It's almost hard to believe that this spacecraft, which faced a potential launch failure back in 1977 due to an early shutdown in part of its launch vehicle, resulting in 1,200 pounds of unburned propellant, has managed to travel roughly 523 million kilometers per year. To put that in perspective, Voyager 1 covers about 1 light-year every 18,000 years. Voyager 1's continued success is not just a matter of robust engineering, It's also due to the remarkable suite of instruments onboard. The probe is equipped with 16 hydrazine thrusters, stabilization gyroscopes, and precise referencing instruments that ensure its high-gain antenna remains pointed at Earth. It also carries an array of 11 scientific tools designed to study everything from radio waves and ultraviolet light to plasma waves and cosmic rays. Some instruments remain active while others have been deactivated over time, but each component plays a crucial role in gathering data about the far reaches of space. Communication with Voyager 1 is achieved via a 3.7-meter high-gain antenna that both sends and receives radio signals through NASA's Deep Space Network. When direct communication is interrupted, an onboard digital tape recorder, capable of storing up to 67 megabytes of data, ensures that valuable information isn't lost and can be sent back to Earth later. By 2023, it was noted that signals from Voyager 1 took more than 22 hours to reach our planet, highlighting just how vast the distances are between us and this pioneering spacecraft. Voyager 1's imaging capabilities are equally impressive. Its cameras have provided us with detailed pictures of planets, moons, and other celestial bodies. Unlike newer probes with fully autonomous systems, Voyager 1's cameras are operated through an imaging parameter table stored in one of its onboard computers. This system, along with the spacecraft's command and control system, CCS, manages tasks like command decoding, fault detection, antenna pointing, and the overall sequencing of operations, a system that has evolved from the technology used in the 1970s Viking orbiters. Throughout nearly 5 decades of operation, Voyager 1 and its twin, Voyager 2, have been beacons of discovery, transmitting a steady stream of data from over 14.1 billion miles away. One might have expected that a spacecraft operating in such harsh conditions would begin to fail, yet thanks to meticulous power management and the redundancy built into its computer subsystems, Voyager 1 continues to function. This longevity is also supported by its power source, radioisotope thermoelectric generators, RTGs. These generators convert the heat released by decaying plutonium into electricity using the Seebeck effect, a process that doesn't require moving parts and is thus highly reliable in the extreme conditions of space. However, the gradual decay of the plutonium means that less power is generated each year, forcing engineers to make tough decisions about which systems to keep active. Non-essential systems, like heaters, have been turned off, and scientists are even considering shutting down one of Voyager 1's instruments if necessary to conserve power. Voyager 2 is expected to be the first to face such measures, though plans are already underway to explore alternative solutions that might avoid losing any instruments on Voyager 1. The recent detection of 775 unknown objects by Voyager 1 has added another layer of mystery to its storied journey. Initially, the data appeared to be corrupted, a problem that was later traced back to an issue with the spacecraft's attitude, articulation, and control system, AACS. This critical system, which is responsible for measuring, reporting, and adjusting the spacecraft's orientation, had mistakenly begun transmitting data through a faulty onboard computer that hadn't been in use for years. Once NASA engineers identified the problem, they redirected the AACS data through the correct computer, restoring normal telemetry. The exact cause of this error is still under investigation, with theories ranging from a faulty command issued by another onboard system to the harsh effects of cosmic conditions such as extreme temperatures or radiation. Space itself is an unforgiving environment. Voyager 1 must contend with relentless cosmic radiation, high-energy particles emanating from distant stars and galaxies, that can disrupt electronic systems and even cause memory errors. The probe is also exposed to drastic temperature fluctuations, sometimes plummeting to as low as -202 degrees Fahrenheit, as well as impacts from micrometeoroids and interstellar dust particles. These dust particles, which can strike the spacecraft at high speeds, approximately 17 km per second, are rapidly vaporized and ionized upon impact, generating brief plasma clouds that create voltage spikes in the instruments. Although these collisions can potentially cause damage, Voyager 1 is equipped with voltage regulators and backup circuits that help protect its delicate electronic systems. Adding to the intrigue, some have speculated that the strange data and behavior observed in Voyager 1's telemetry might be linked to extraterrestrial influences. According to this hypothesis, an advanced alien civilization, far more technologically advanced than our own, might have encountered Voyager 1 as it wandered into their cosmic neighborhood. Such a civilization, with a deeper understanding of interstellar phenomena, could conceivably interfere with or even commandeer the spacecraft, leading to the unusual data signals we've observed. While this idea remains highly speculative and is difficult to prove with current technology, it certainly adds a fascinating dimension to the ongoing mystery. In summary, Voyager 1 stands as a testament to human ingenuity and our relentless quest for knowledge. From its historic launch in 1977 to its continued journey through the outer boundaries of the heliosphere and beyond, it has redefined our understanding of the cosmos. Whether it's the gravitational maneuvers that allowed it to visit multiple planets, the sophisticated suite of scientific instruments that continue to send back invaluable data, or the recent detection of 775 mysterious objects that has rekindled debates among scientists and enthusiasts alike, Voyager 1 remains one of our most remarkable achievements in space exploration. As NASA engineers and scientists work tirelessly to monitor and extend Voyager 1's mission, adjusting for voltage fluctuations, managing dwindling power supplies, and even contemplating measures to preserve every remaining instrument, we are reminded that our exploration of the universe is a continuously unfolding story. Each new discovery, no matter how unexpected, brings us one step closer to understanding the vast and complex cosmos that surrounds us. So while we wait for answers to the mysteries of these 775 unknown objects, we can only marvel at the enduring legacy of Voyager 1, a tiny spacecraft that has traveled farther than any other, bridging the gap between our small blue and the infinite expanse of space. Thank you for joining us on this journey into the depths of interstellar space. If you found this exploration of Voyager 1's incredible story as fascinating as we did, click on another video on your screen for more mind-blowing insights into our universe.